Okay, I know I said I was going to be done with acids and bases, at least the basics, but for the moment we need to cover the leveling effect real quickly because it's the tail end of our acids. The leveling effect plays a much larger role in second semester chemistry or second semester OChem. But really what it's saying is that our solvent, or what it's saying is that we can't have a stronger acid or base in our reaction than the solvent will allow. Okay? So for instance, if we had an HCl solution, so HCl aqueous, we've got two species, theoretically two species at a first level. We would have hydrochloric acid floating around and we would have H2O floating around. This has nothing to do with the fact that we would also have other reagents present. Okay? So, but we'll throw in another reagent. We'll throw in something. Let's throw in a base. Okay, general base, so it just has electrons. If I was to now draw a mechanism to explain what happens when I mix HCl with the base, how would I go through and do it? Okay. Well, one kind of standard default would be to say, well, the base shares electrons with the hydrogen of our acid, and then those electrons then go to the chloride and we'd have our product. Okay, the end result of this would be that I would have the base with the hydrogen connected to it, now positively charged, and I'd have chloride ions floating around. Okay, note in this case, the only thing that really changed were the reagents that we put in there. The solvent did nothing. Okay, so our solvent, H2O, as a liquid, really did nothing except brought these two solutions together. Okay, and what the leveling effect is saying is that this mechanism, as I've got it drawn, is technically wrong. Okay, how do I know it's wrong? Okay, well, it's wrong because water, being in a far greater concentration than HCl, will very likely react with the HCl first in a simple acid-base reaction to form H3O plus, okay, and Cl minus. Okay, that's a Cl. I don't have HCl. What I have is H3O plus and Cl minus. So now when the base comes in, the base reacts with the H of H2O, or of H3O plus, to give me my H base, and note I still have Cl minus and I still end with H2O. Okay? So it becomes kind of this weird gray area because when we talk about it, like, well, we get the exact same results at the end, but it's how we drew it or represented it that mattered. Okay? And as you probably should have learned by this point in your chemistry career, the how you do something is just as important as the end result. Okay? So the leveling effect is trying to get you to think about that and approach that logically, and to realize that you shouldn't have stupidly strong acids in solutions that are minimally basic, okay? Because you'll get pre-reactions happening. Okay, so it's a relatively small thing. I just want you to be aware of it. We will talk about it in a couple cases, I think, this semester. We'll look at very particular cases that reference it, and we'll for sure see it in second semester. It's a larger issue when we're looking at trying to create a mechanism. Okay, and now I'm done, I promise.